assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
I have prepared a little bit for number 36 by drawing this lovely diagram of our wires, which are solid black. The first one is known the current and direction. And we know that the magnetic field is 0 at a certain point closer to the first wire. So at R equals 2.2 centimeters, measured from here. So we are wanting to find the current and direction for the other wire down here. So we'll call this wire A, this wire B. And right away, we can figure out the direction by knowing our tried and true right-hand rule. So if you look at the current if you look at the magnetic field which circles around this wire like this, the only way to cancel this out is to have something that circles around like this. And if you check your right-hand rule, you will see that it is only possible for a current that is in the same direction as wire A. So there we go. We've got the direction part. Luckily, that wasn't too bad. But to get the magnitude, all we're going to need is to use the magnetic field from a wire, and we'll figure out a ratio for the currents. So to solve for that, we know that we have a B net of 0. So this is our boundary condition, if you will. And that is when the BA plus the BB, which these are the magnetic fields from A and B, are added up and are equal to 0. And if we assume the direction being implicit in there, that will save us from having to deal with the vector stuff. But let's go ahead and write it out. So you get mu I, we'll say A, over 2 pi R1, 1A, minus, because we know that they are in opposite directions here, over 2 pi RB. Okay, well, if we move 1 to the other side, we see that we're going to be able to cancel out most everything. So I'll go ahead and do it, just to be explicit. All right, so we see these cancel. Both of these cancel, leaving only the ratio of the current to the distance. But luckily, we happen to know RB, because RB is just the total distance, which we'll call D. So RD. D minus RA, which is here. So rearranging this just to get what we want, which is the current of B, we see that it is a simple ratio of RB, which is D minus RA over RA multiplied by the current A, which is 2 amps, like we know. And plugging everything in here, we get a current of 4.4 amps, and it is in the same direction as the other wire. So All in all, not that hard of a problem. The only thing that we needed to consider are the what leads to a cancellation of the magnetic field, and that's the main trick.